Chapter 6, Introduction to Cisco Routers and Switches. This is, I think we're past, I mean, there's always going to be memorization, but we're past a lot of the just like hardcore memorization stuff, and we're actually starting to get into, actually working in routers. I think we're still a chapter or two away from, 2 chapters away from really command line stuff, but we're getting there now, where we're more on the logical part of it. So start off talking about interfaces and modules. LAN interfaces, pretty obvious. Generally it's going to be Ethernet ports, the LAN side, where the customer, the users are connecting their individual PCs. And then WAN interfaces, you've got a lot of options. Some of the ones that they mentioned in the book: a basic rate interface, a BRI. For ISDN service, it actually consists of 3 logical channels on that one interface. You've got 2 64 kilobit bearer channels that actually handle the data, and then you have one 64 kilobit data channel that actually handles some of the signaling, so that those 2 bearer channels can traverse data. And then you've got synchronous serial, asynchronous serial, as well as the high-speed serial interface. The serial cables, like a lot of times you'll see, are on the higher end, like Cisco routers or really old Cisco routers. Usually it's a cable connecting one router to another. Like if you guys end up getting a CCNA or CCNP lab equipment off of eBay real cheap, you'll get like a really old 2501 or 2502, and most of the time they've got the serial connections on there that go between the various routers. And then T1 controller cards, can be either a solid interface or an interchangeable wick on the back of the Cisco, where a T1 will actually terminate on there for your WAN connection. DCE and DTE. This kind of comes up periodically throughout the book. DCE is data communications equipment. It's going to be like a modem, a CSU, DSU channel, something that's connecting on the other side. Channel service unit, data service unit. You see that term thrown around a whole lot if you guys do any troubleshooting on T1s. If the carrier can loop the smart jack, but they can't loop the CSU, DSU, it usually means that the actual router itself is down. That they're saying that up to the smart jack where they're getting good connection is fine. But there's either an IW or a router issue that they're not able to hit that CSU, DSU, channel service unit, data service unit. And another DCE example would be a basic rate interface network termination, BRI in T1, like we just talked about for ISDN. And then data terminal equipment, DTE, would be like a router, a PC, or a server. Okay, this is actually kind of an important slide. Understanding like what the various Cisco memory components are, and like where different forms like the configs and the iOS and all those things are located is pretty important to like being able to troubleshoot like over time, especially like if you're getting a failure like as the router's powering up, or it's coming up but you're not seeing the config you're saving in there, that kind of thing. So the 4 main types of memory in virtually every Cisco router are the ROM, the flash, the RAM, and the NVRAM. Before I really go into each one of these individually, it's important too that you guys know the difference between volatile and non-volatile when they're talking about memory components. Volatile means you lose power to it. Whatever data you had on there is gone after it boots back up. Non-volatile retains that information even after a power cycle. So your flash. Thinking about your a PC, like your RAM in your computer. It's just used for holding whatever data you've got while that computer's on, like whatever it's trying to pull up. But your hard drive is going to hold on to that. So a hard drive would be a non-volatile example of memory, and your computer RAM would be a volatile example of memory. So starting off, ROM, it's read-only. You cannot write to it. It's stuck there. Whatever data's on there was put there directly by Cisco in this case, and you shouldn't be able to change it. If you can, there's a big problem. It is non-volatile, so whatever they've programmed in there is going to stay there. So the ROM on a Cisco router is going to contain the basic code for booting the device and maintaining the power on self-test, the post, ROM monitor, ROM-mon is commonly called, and the bootstrapped and RX boot. And I'll go into more detail on some of those things that are held in ROM later on in these slides. Either these slides or the next ones. Flash is readable, writable, and non-volatile. This is usually where the Cisco IOS is located. The IOS, of course, being the operating system that the Cisco platform is running on. So you can read it there. You can write to it to change it. Like if you need to upgrade the iOS, if you power off the device, you're not going to lose whatever's in the flash. And then the RAM is volatile. Data is lost when the router's power cycle, as we discussed already on volatile and non-volatile. The RAM is where everything is basically held while the computer's running. So it's used for short-term storage of the iOS and the running configuration. So even though the iOS is always located in flash, whenever the Cisco router initially boots up, it's going to reload that, make a copy of that iOS, and put it in RAM so that it runs while the router is running as well. So when you've got the router powered on and working, you've actually got the iOS in two locations. You've got it on the flash there to stay there and be loaded or be changed if you need to change or upgrade the iOS. Then you're also going to have it running on the RAM. And the same thing with the running configuration. The running configuration is actually pulled, well, when we get to NVRAM in a second, is pulled from the startup config in NVRAM. Whenever the router's up and running, you're going to have the running config also running on RAM. So iOS, running iOS basically, and running configuration located in RAM. And I said that already. iOS is copied from flash to RAM during boot up. Startup config is copied from NVRAM to RAM during boot up. And then we pretty much already touched on it, but NVRAM, it's readable and writable, non-volatile, much like flash, and it is where the startup configuration is located. So like, for instance, on most commands, like configuration change commands, if you make a change in a Cisco, but you do not write to memory, it's going to make those changes to the running configuration, but without making that save, it's not going to save them to the startup configuration that it's going to reload whenever you reboot the box. So that's something to keep note of.
Is it sort of one of the advantages to having that in two separate memory locations?
Yeah, kind of, because you can depending on what you're doing, you can actually test out some stuff. Like, we know from working in the NOC, like you may want to try something. In fact, a lot of times when we're making just like small configuration changes and we're trying to fix a site where we're not really sure of the full impact of making those changes, we'll set a reload in like 15 minutes. That way, if we make some changes, we get booted out of the box, we've made those changes to the RAM, but we have not changed whatever's in flash or NVRAM. So like if you make a change, you get booted out, and after 15 minutes you can't get to the router, you can't get someone to power cycle. After 15 minutes it'll power cycle itself, and it's going to come up with whatever's in the NVRAM automatically. That way you don't have to worry about just completely destroying the box while you're making some on-the-fly changes.
Well, that's a good point to remember. That's why there's two, because it seems a little confusing. Like, well, why would I have two? And that's just one of the little advantages to having it that way. So
but also the downside is if you save the running.
Right.